clear it up.
Hey everyone, today we're going to be talking about similar polygons. And basically there are two identifiers that tell you that you are working with similar polygons. The first one is that all corresponding angles are congruent. The second one is that all corresponding sides are proportional. So if we are given two similar or proportional polygons, we can identify what the missing sides or angles will be, and also we'll be able to tell whether or not two polygons are similar. So for a quick example, let's take a look at triangle ABC and triangle DEF, and we can see here that this symbol here means that they are similar. So if triangle ABC is similar to triangle DEF, and this angle right here is 25 degrees, that tells us that this angle here also has to be 25 degrees. Also, if we have this angle here as 55 degrees, that tells us that this angle here must also be 55 degrees. So all these angles will be congruent. So this angle up top here would be 100 degrees, which means that this angle up top here would also have to be 100 degrees. So as we have previously mentioned, if we have similar triangles or similar polygons, each corresponding angle will be the same. Now, this is also going to have similar consequences for the sides of the polygons. So let's take a look at triangle RST and know that it is similar to triangle WXZ. So let's take a look at the sides. So the sides here are not going to be congruent, or not necessarily going to be congruent. Here we can see that the ratio between RT and WZ is actually going to be 2 to 1. So we have a 4 and an 8. 8 is twice that of 4. So if I were to have RS be a 6, what value would this be right here? Well, if the first pair of sides, RT and WZ, have a ratio of 2 to 1 or 1 to 2, then this side right here will have that same proportion. So if this is a 6, this has to be twice that, so we're stuck with a 12. So here we can see how the sides of parallel polygons relate to each other. Corresponding sides will be proportional. So in this case, we know that each side of the polygon, in this case a triangle, will have the same proportion. So once again, we have 4 and 8, 6 and 12, and let's say that this is 3, and this will be 6. So here, RT is proportional to WZ, RS and WX, and XZ and ST are the corresponding sides, all having the same proportion of 2 to 1. So let's take a look at an example that I want you to try on your own. So this question is going to ask you, are the following triangles similar? Let's take a look. So let's take a look at this diagram here. We have triangle ABC and triangle DEF, and we want to know whether or not these two triangles are similar. So if you can look at the diagrams, I know that they're not probably drawn to the best scale, but use your imagination. So we have ACB and DFE both have an angle of 75 degrees. We have angle FDE with an 80-degree angle, and lastly ABC has 37 degrees. So using what we know about similar triangles, are these two triangles similar? Take a minute and figure it on your own. Please pause the screencast if you still need more time. Otherwise, let's take a look at this problem. So if these two triangles are similar, then we know that this angle here has to be the same as this angle here, which would mean that angle DEF would have to be 37 degrees. So if that's the case, we have an 80 degree angle, a 75 degree angle, and a 37 degree angle. What is the issue with that if those three angles are in a triangle? What do we know about the angles in a triangle? Well, we know that they have to add up to 180. So here we have 80 plus 75 plus 37, which does not equal 180 degrees. So therefore, these two triangles are not similar. We also could have used triangle ABC to figure out the same thing. Knowing that they're similar, that means that this angle would have to be 80 degrees, and we'd be in the same predicament that we were for triangle DEF. Well, that is about all that I have for you today on similar polygons. I have a try now problem for you to do for homework. It will involve similar quadrilaterals. So we've been talking about triangles. Let's see if we can take that a step further and work with similar quadrilaterals. So good luck, and I hope you enjoyed this screencast.